All right, hey everybody. Today we're going to be reviewing two LeetCode problems. The first one being LeetCode problem 1413, and this one is minimum value to get positive step-by-step sum, as well as find the highest altitude, and that's problem 1732. I chose these two because I solved both of them using in a version of Prefix Sum. So that's the technique I'll kind of be explaining today. And basically what prefix sum is, it's the easiest way to explain it is like it's a running sum. Some people call it a cumulative sum. I think that's how you say that. And here I'll show you an example. So there's an array where you have five numbers like this. And in a running sum or a prefix sum, usually what you do is you want to create a new array called prefix or whatever you want to name it, and then this is where you'll keep your running sum. So for example, you'll do 1 because you start at 1 or whatever your beginning index is, and then you'll add the next index, and that'll be your new value down here. Then whatever that value is, you add with the next index of the original array, and then that's your new answer. And then you take that and add that to the next step, blah, 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 that's your new one, and you keep going until you're at the very end. So an example of that is like this. So for example, 1, 2, 3, 4, 5, you start with 1, then you add the 1 to the 2, then you get 3, and then you add the 3 to the 3, and then you get 6, you add the 6 to the 4, and then you get 10, and then you add the 10 to the 5, and you get 15. And this will be your new prefix sum array. Um, Prefix sum is most of the time you'll see these problems where you need to set up prefix sum in order to do um, like other logic in the problem. I don't know if I'm explaining that right. But sometimes you'll get problems like this where all you have to do is worry about the running sum of numbers and you don't have to worry about any other kind of logic or like using the prefix sum as like a prereq to something else in the problem. In this one, it's just the um, prefix sum or the running sum that we're worried about. So we'll do the first one first, the minimum value to get positive step-by-step sum. In this one, the problem statement says, given an array of integers nums, you start with an initial positive value, start value. And in each iteration, you calculate the step-by-step sum of start value plus elements in nums from left to right. Return the minimum positive value of start value such that the step-by-step num is never less than 1. Um, when I first looked at this, the first time I solved it, it was really confusing what like what exactly they were asking for. But when you look at the example, it makes a bit more sense. So they'll give you an input of nums, and then you're supposed to return the minimum number or the minimum integer you need to input as start value in order so that in during the running sum it'll never fall less than 1. And there's a pretty neat trick with this problem that you can use when you're doing your running sum, and I can show you an example of that. So we'll take the first example that they give us here, the first input, which is this array of nums, which is -3, 2, -3, and then I think 4 and 2. Yeah, 4 and 2. Ooh, that's an ugly 2. Um, okay, yeah, that's a 2. And then the trick is you want to take the running sum of this. So we'll do that really quickly. So you'll start at -3, then you add the 2, -1, add the -3 again, and that'll put you at -4, and then add the 4, the positive 4 this time, and you'll be at 0, and then add the 2, and you'll end at 2, and this will be the running sum. This whole array will be the running sum of this input array. So the trick here that I used is to find the minimum value in this running sum array, which in this case is -4. And now you know that if you never want this to fall below 1, all you have to do is make sure that your starting value is equal to the lowest value and then add 1, because remember, you don't want it to fall in the problem. They don't want it to be less than 1. If the case was less than 0 or less than or equal to 0, or no, yeah, sorry, if the case was that they wanted it to never be less than 0, then you would just flip this. You would have to make sure that your starting value would be 4 in this case. So you would always want it to match the lowest value in the running sum. But in this case, being that they don't want it to fall less than 1, all you would have to do is add 1 to this. So in pseudocode, or not even pseudocode, but just as an example, in this case, it would look like this. Yeah, so it would look like this. So you would want, in order for this to be 5 in this case, because you want it to match 4, because it's -4, so you want it to match 4 and then add 1, so you want it to be 5. Um, so what you do, this is kind of what it looks like, is you take the negative of whatever this value is, which will turn it positive, and then you add 1, and that'll give us 5. Because when you input this -4 here, it'll be -4 plus, or sorry, it'll be like this. And then this will flip to 4, and then you add 1, and then that'll give us 5. Ugly numbers today. It's okay. So yeah, so that's basically it. So now the main thing you need to do is, okay, how do we find the minimum value in this array during a running sum? And it's actually really easy. The only variables you need is just 2, and that's your total as well as your minimum value, which will be your answer in this case. That'll be what we're returning. And you can set both of those to 0. And then all you need to do here is just loop through. Oh, I'm in the wrong problem. Whoops. Same thing though. So you want to initialize your total variable as well as your min val, which will be your minimum value. Set those to 0, and then you want to loop through the array of nums that they give you. And then you want to say, total. Remember, it's a running sum and it starts at 0, so you just want to do a plus equals. So total plus equals num. And now, just to visualize, total right now equals 0. And then we're at the first index of this array. So now we're adding that -3. So our value is -3, right? For this first iteration. And then you want to do that. And then once you have the new running sum for that, or at that index, what you want to do is you want to say your min val is equal to the minimum of min val or your total at that iteration. And basically what this is doing, because we initialize min val at 0, it's comparing the answer you just got in the running sum to that 0, and it'll set min val to the lowest of the two. In this case, that's -3 for that first iteration. So we can just keep moving through. All right, and as soon as it's done looping through this for loop, going through all of the nums and the input that you're given, all you have to do here at the end is return, and this is where you'll use that formula that we came up with right here. So this is all you'll return right here. And this LV is what your min val is going to be. That's where min val goes. So that looks like this. So you'll return the negative of min val plus 1. And remember, that's the exact same thing we wrote right here. Right? And when you run this, you should get back positive test results. Yep. So it passed the first 3 cases. So you can submit this. I won't submit it. I've already solved it, but I won't submit it. But this is how you get the minimum value to get positive step-by-step sums. There are other ways to solve this, but this is kind of a nice little cheeky way kind of to solve this problem. So yeah. And then this one from earlier, another one that's similar. This one is the same thing. The only thing in this one that's different is you're finding the highest altitude instead of the minimum. So in the last one, we were looking for the minimum value, and then in this one, we're looking for the highest altitude, so highest value. So it says here, there's a biker going on a road trip. The road trip consists of n+1 points at different altitudes. The biker starts his trip on point 0 with altitude equal 0. You are given an integer array gain of length n, where gain at I is the net gain in altitude between points I and I+1 for all iterations in between 0 is less than or equal to I or less than n. Return the highest altitude of a point. So Again, this was another one where the description was like really confusing, but then when you look at the examples that they gave you, it turns out to be the exact same thing as the other problem, just that you're looking for the highest value now. So same thing, you have an input of arrays, and you want to look during the running sum, you want to look for the highest point in the array. And in this case, you can see in this example, when they did a running sum of this array, this is the answers right here that they were coming back with, or the sums. And you can see that the highest point when they were going through the running sum was 1. So that's the answer you return. So if you recognize that, then all you have to do is say total equals, and then max out is what we'll call it in this one. And again, set them to 0 because your total, you want to keep it 0 because it'll be the start of your running sum, and then max alt is just this right here. They told us that altitude from the beginning will equal 0. So yeah, and then it's the exact same thing. You'll say alt, short for altitude in this case, in gain, and then you'll say total plus equals alt, or altitude, and then you want to set max alt, this is where it'll be different, equal to the max function instead of min function, equal to the max of either total at the moment or whatever is already in max alt. So there you go. It's the same setup, just instead of looking for the minimum, we are returning the max. And we don't have to do any special math with this one, just because in the other one it was dealing with negative numbers and having it to be avoiding like it dropping less than 1. In this one, all you have to do is return the highest altitude. So you can just return max alt at the end, and this should be your answer. So we can hit run, and we can see that it accepted both of the example test cases. So we can go ahead and submit this. I saw this one as well, but I'll just submit it again. And it passed all the test cases. So you can see 80 out of 80 test cases passed. So there's the answer. There's one of many answers for this one. So yeah, that's how to solve minimum value as well as finding the highest altitude or highest value.